Yes, ma'am. Yeah.
Yeah. Okay. So today we all are here to discuss about the some biomedical images from cancer point of view. So we will discuss analysis of mammographic images. So outline of our complete presentation. I will start with the introduction. Then we will talk about how exactly the mammographic images can be used. What are the various methods for the early detection of breast cancer? Finding of mammographic images, what we should observe in it. Then what are the various advantages and limitations of mammographic images? Now, if we want to work in this area, then what is the data set which we can use so that by using that data set, we can train our algorithms. Then one method I have explained over here, which is segmentation by using vector quantization. So that I have included here. And then we will discuss about how exactly different machine learning algorithms can be used for making this diagnostic process as an automatic process. And after detection of your tumor, how exactly your ML or AI is going to help us in this case. So this is how we will proceed. So as all of us, we know that out of 10, nowadays I think 2 or 3 women are going under this particular condition. So breast cancer is a prevalent cause of death. So this is the only one type of cancer it is a widespread among women worldwide. The study says that even the early detection, if I'm going with a physical examination in that case, also the breast cancer is a very dominant thing in case of women. Many imaging techniques we are using in this case, obviously, for targeted detection, so that we can reduce the number of deaths and a proper treatment can be given. So now these technologies have greatly increased the knowledge of what is a normal tissue and what is a disease. Okay. And then different types of research is going on for these critical components which are there, which is going to help us for a diagnosis and for a treatment plan. Now, with the increasing size and the number of medical images, now it becomes very necessary for us to come in picture because as the data number of images goes on increasing, how many radiologists is going to invest their time per image that is going to help. And because of that, obviously, accuracy is going to be. So this is the area where engineers come in picture and how we can help the society. In the last few decades, data mining and machine learning techniques have been developed specifically for breast cancer detection and classification. So we have 3 main stages over here. We will talk about the ML. First of all, whatever data set is available with us, we need to go for processing there so that whatever data we are talking about, it should be compatible and proper. So then pre-processing. After we will go with the feature extraction. Say set of features are there. Now which features we should consider first of all, so that those features will help us for the classification. Now before going in detail to this all these techniques, first of all, if we are going to talk about mammographic images, then it becomes necessary for us to talk about how exactly mammography images look like and what are the various things related to that. Without knowing that, we can't do any type of research. So if any image you are going to consider, any modality you are going to consider for any type of research, then each and everything related to that image we should know. So we will just brief overview of about this. So when we talk about feature extraction, we have a number of image properties and that we need to select. And then we can have a transform domain thing or we can have a spatial domain thing. And in that list, we can have a number of transforms which can be used so that the image can be represented how exactly the image can be seen in the old format that we see first. Okay. Now, before starting with the presentation, or you can say starting with my topic, I have one small question to you. Uh, the thing is that which is the most widely used technique for early detection of breast cancer? You have to go for here as it is mentioned. Uh, let's see. Responses are not accepted. You have to go with the polstv.com. Yes, you just go on this polev.com, and then you have to enter this Saylee Gharge 816, and then you can join. Enter your name and you can join. Because in the presentation mode, we can't see this, but I have to go in the presentation mode to get the answer. I think I have activated. Now you can give your responses. Is it possible to enter over there? Because any result I can't see. I think some problem is there. Maybe some problem. I will proceed otherwise. Because I can see the 63 participants are there. Is there anything in the chat box? I think I should proceed otherwise it will waste time. Okay, I will answer for this question. Which is the best or a most widely used technique for the early detection of your breast cancer? The option was MRI, PET scan, ultrasound, mammography, and none of the above. In this case, obviously, we have to go with the mammography because this is a widely used technique. Now, why this is a widely used technique? Because when we compare it with the other techniques, first of all, it is very easy. Second thing, the radiation which we are getting because of this is very less. If we will compare this with the radiation, how much radiation and what radiation we are getting for 3 days, continuous 3 days by nature, that much radiation only we get by the mammography. And nowadays, if you will see, even we can see that uh, in our body profile, when we go for a full body checkup, in that also we are going with currently they mention that mammography images also along with your blood report. So it is as good as very simple to that. MRI images, obviously it is better than mammography images, but it is if we compare the cost of it, then it is much more expensive than your mammography image. But for early detection, no one will suggest MRI. If we will go with some stages and if, some further clarification we require, in that case only ultrasound or MRI images are suggested for the research. So we will discuss now with the mammography images. So mammograms are probably the most important tool doctors have, not only to screen for a breast cancer, but also to diagnose and prevent. It means that when screening is done, after that you want to diagnose, and then after monitoring you want to evaluate how much or which stage or which grade this cancer is. So the technique we are using for last 50 years. So for women, when exactly we should use it? So generally, women above age 40 generally go with this because there the chances of the risk of your breast cancer increases. But it is not like that. If you feel that some abnormality is there, in that case also you have to do it. So how important mammography is? So since 1989, more than 500,000 breast cancer deaths have been prevented in United States. So this is because of your mammography and the improvement in the treatment. This is what a study they have published on 11th Feb 2019. Now, one thing which I want to note down over here is that mammography doesn't or don't prevent breast cancer, but they can save lives by finding breast cancer as early as possible. So this is one technique or a modality which is going to help us to find out whether breast cancer is there. So early detection is possible by with your mammogram. So how exactly the early detection can be found out? So the first very easy thing is breast self. First of all, you can self-examine yourself whether any lump is there, any abnormality is there, color variation is there, size variation is there. That you need to check out. If you feel and then if you couldn't understand what exactly these variations are, then you have to go with the clinical breast exam. The clinical breast exam is nothing but the medical expert will do this breast examination. And after clinical breast examination, if doctor feels or doctor thinks that yes, you have to go further with some modality or any technique, then mammography is the first choice of the doctor to go with the selection of the image. So then mammography images will come. Now, various categories are there while we are going with the mammography. So we have a three tests: screening test, diagnostic test, and monitoring. Now, what do you mean by this exactly by screening test, diagnostic, and monitoring? Now, whenever you feel that it becomes necessary for us, now you have to go with the mammography since you turn above 40. So, to be on a safer side, you go for the screen. You want to find it. So, in that screening, if doctor feels that is some abnormality is there, something in that case, then you will go for the diagnosis. Now, diagnostic test is also mammographic technically, but the only thing is that the images will be taken to a specific part and more number of images with the different angles. And once the cancer or a tumor is detected, then the monitoring will start because once it is detected, then it becomes necessary now then that to find out it is at a which stage and at which grade. And depending upon that, how exactly we proceed with the your you can say what type of a drug you are going to use or which method you are going to use. Whether it becomes necessary that you should remove it at the first instance or chemotherapy technique or you have to go with the radiation technique. What exactly we need to do with that? So that will be decided, and then after that, the continuous monitoring will be done. Now, when we talk about mammographic images, we have two types of. First of all, a film screen. That is what we have seen in X-rays also. So film screen is a one and another one is a digital. The film screen is a normal X-ray technique where we get that particular image on a thin film. That is our film screen. And a digital image which we can directly see in a digital format, and directly this can be sent to a doctor and doctor can observe on the computer screen. So these are some images which I have showed you here. First one is analog and digital. So here you can make out the difference between these two. Nowadays, all are going with the digital images because that technique is a very good technique. Now, what exactly doctor will try to find out from your mammograms? Three things are there: calcification, cyst, and fibroadenoma. Now, when we say calcification, now what do you mean by this? These are the tiny flakes of calcium. It's like a grains of salt, which sometimes indicate the presence of early breast cancer. It is possible, but not all. Then we have a cyst, which is a fluid-filled mass. It is not like a solid tumor. It is like a fluid-filled mass. Then we have a fibroadenoma. These are the movable, solid, rounded lumps made up of normal breast. So these are the three things which we can find out in mammogram. And after that, then if something is there, and if doctor feels that yes, there is a chances that this particular uh, group of calcification coming together, and then it is going to form a cyst further. So these are some diagrams, uh, images which indicates how exactly the first one, if you will see a salt like a flakes, or you can say a dots you can see in that image. This is nothing but the calcification. Then second diagram you can see which is a cyst, and third one is your fibroadenoma. So these are the three things which can be seen in your mammogram. Now, obviously, every person has a different intensity of your fats. So if a fatty breast is there or a dense breast is there, so depending upon that, now this particular diagram shows that the red mark. So if the breast is a fatty breast, in that case, even though a small tumor is there, then also it becomes very visible and very easily it can be found. Whereas when it is a dense breast, now in that case, even though my tumor size is very big, then also it becomes difficult for us to find out where exactly the tumor is. So this is the basic problem. Now how to do it? So these are the area where your another images or another modalities will come in picture. Now when we talk about whether my tumor is benign or malignant, no, benign or malignant, it means that cancerous and non-cancerous. It means that whether that particular cyst is going to trouble you or not. So this is my normal mammogram. First image is small first image. Second one is a benign cyst, which is not cancer. And third one is a malignant. It means that it is going to spread further and it is going to trouble. Which is a cancer. So obviously, when looking at the image, it is not possible for us to observe. So in that case, obviously biopsy comes in picture. Why we need to do a biopsy? Because looking at the image, texture of that particular tumor is not clear. So now we want to find out if cyst is there, whether the cyst is benign or malignant. Then biopsy comes in picture. So because of that, if your imaging technique which we are using is a proper technique, then unnecessary that we will not go with the biopsy. Because so many times it happens that mammogram is, since mammograms are not perfect, so we will discuss that also. What are the advantages of your mammography images? It involves minimum radiation exposure, and it is a non. It is like something we are not going to introduce in our body. That is the main part. Because of that, generally doctors suggest mammograms. And the radiation, as I discussed previously, average 3 months period, whatever natural surrounding radiation we will get, that much radiation we see in mammograms. And obviously, the cost is around something 1,500 or 2,000. So cost is also not that huge, so we can go with that. Once in a year, very easily we can do that. Obviously, limitations are there. The main risk of mammograms is that they are not perfect. So what exactly is happening if I'm saying that it is not perfect? It means that normal breast tissues can hide a breast cancer so that it doesn't show up on the mammogram. So this is called as a false negative. Even though cancer cell is there, we can't see. And mammography can identify abnormality that looks like cancer, okay, but it turns out to be a normal. This is my false alarm, which is my false negative, false positive. Now this false negative and false positive we need further, because now we want to find out what is the accuracy, what is my AUC, what is my ROC, what is my log loss. All this we need to find out further. So for that we need this false negative and false positive. True positive, true negative, even that. So to make up these limitations, then we can go with more than mammography. So next choice can be your MRI. Now we know the basic problem that different centers have a number of radiologists with them, and as we have seen, the patient goes on increasing. According to that, the reading of your images becomes very intense, and number of, or you can say, workload will go on. Now, since we know that this is the case, sometimes it will be a false positive or false negative in that case, then the second radiologist is required so that it will reduce the chance of missing some problem. So otherwise, about whatever report we will give, that will be not right, and it will lead to maybe a biopsy and unnecessary problem to that particular patient. So it means that we need a second opinion. So everywhere it is not possible to have a two radiologists at the center. So what can be done in that case? We can use computer. So computer edit detection can be used. So it will guide. If it will detect that particular region, particular spot where the tumor is there, what is the area, and if it will segment that particular part, then it will be much more easier for the radiologist to examine that particular area and to decide what can be the further intervention. So it is like helping us. Your computer system will help us further to find out whether any problem is there or not. So evaluation in from that point of view is very important. Now to do all this thing, okay, we need a data set. So number of data sets are there in case of the mammography. We have a PCDR data set, we have a computer vision and pattern recognition, we have a within breast cancer data set which is provided by UCI. Then we have a mini-MEAS data set. So many data sets are available. You can use those data sets. And in your data set, even they have mentioned which different features they have selected. What is the area in which the tumor is there? Whether really a tumor is there, any abnormality is there, whether tumor is benign or malignant. Each and every information is mentioned in your data. In some database, even they have mentioned what is the center of your tumor and what is the spread of that tumor, what is the complete area. Even that is mentioned. So it becomes very much helpful for us to train our algorithm, because if we will feed this proper data, okay, with patient name and each and everything, specifically age and gender, as here you can see, here first image is of a patient who is age 53. gender female is a mention, it means that it is possible to have breast cancer in male category also. Okay, because there always we think that it will be case for the female only, but it is not like that. It can be with the male also. Only the thing is that percentage is very less. But even though percentage is less, death rate is more in that because tissues are directly connected with your chest. Okay, there is no that much density. So if it happens with the male, then it is much more problem. Because one survey says that out of consider 5,260 was the number where the male found out with the breast cancer, and out of that 500 was a death. That number was given as a death. So you can imagine how much severe it is in that case. Okay. So now we will discuss with how exactly the segmentation can be done. Okay. So I will just brief about it. Here in this case of your segmentation, we have used vector quantization using statistical properties. So for code book generation, number of algorithms we can use. So here the number of algorithms have been used for code book generation, which is LBG, KPE, KFCG, and modified K. Now LBG is a very old algorithm which we can use. K-trace proportionate error algorithm. This was which we use K-tracer's algorithm. K-tracer is my PhD guide. We come up with this KP vector quantization for code book generation algorithm. Then we have a K-trace fast code book generation algorithm, KCG. And then K-means algorithm we all know, which we modified a little bit. And then we have used it for code book generation. Now, how exactly we will proceed? First of all, whatever image is there that we will read, we will find out all statistical properties. Here I have mentioned only probability, entropy, and variance of the image. And then we have equalized this probability and entropy. We have equalized probability image and equalized entropy image. Now here to calculate this probability, entropy, and variance, we are not going to use GLCM anyway, because GLCM technique needs more time and is much more complex. So we have come up with a method where directly we can find out probability, entropy, and variance. After doing that, this image we will give as input to form a code book. So generation of a code book by using two-level vector quantization. It means at the first level, you will get a code vector of 128. And after getting this 128, then you will get the 8 code vectors. Same thing will be done, you will do for 128 to 60. So two things are there, 128 to 8 and 128 to 60. And then you will display output image of each code vector. Okay. If you will have a 128 to 8, it means that at the output you will have a 8 code vectors. And if you will use 128 to 16 in more detail, you will get 16 images. So how exactly these images look like that? So this is a result of KFCG code book. Any statistical parameter image we haven't used as an input. Only we applied KFCG over here, and 128 to 8. This is the case we have used. So you can see your first original image, then second is your segmented image in gray, and then the third one is a segmented colored image. So very easily you can make out, and the clear boundaries of your cyst, or you can say tumor, can be seen very easily. Now, if you want to separate this tumor from the rest of the image, then you have to go with the individual code vector image. So first code vector you can see where you can see tumor. The side portion is always there because when you go with the mammography, that side portion always will come. Then the second code vector, third code vector. So in the second code vector, you can observe whether your tumor is going to spread further or not. So whether it is a metastatic or not, that information further we can get. But here, very easily you can get what is the area, what is the centroid, and how much it is spread. So this is the normal 128 by using KCG. If I will use 120 to 60, now you can see how in detail we are doing as we are using 120 to 60 for first 4 code vectors are shown. So in previous, if this is a tumor size, now you can see in much more detail we have shown, and now one more layer is separated. So what we are trying to do over here is we are trying to segment. Then we have just come up with the number of photon generation dividers. So first upper line is by using your LPG, where code vector is 128 to 8. Second image C is LPG 128 to 16. Third one is a KPE 128 to 8. Fourth one is using KPE 128 to 16. Your lower line or a row indicates that KFCG 128 to 8, then KFCG 128 to 16. Then my K means using K means 128 to 8 and 128 to 16. If you will observe, approximately all images are approximately in a similar fashion. Now, colored we have used only to indicate different code vectors. Otherwise, colors are not advisable to use because gray colors indicate specific thing for doctors. So whenever they observe, they need those gray colors. So So if you will observe in 16 we are going in detail and 8 we can see this state spot. So all are given approximately same result. So in that case, we have to check which one actually doctors feel it is good. Okay, now this is a general thing where we haven't used any statistical property. So now here we will use some statistical parameters and then we will apply our LPG, KP and KFC. So here in the first two columns, we applied probability and next two columns we applied entropy. So obviously you can see variations over here. The small dots you can see as we go further with the entropy. So here variations can be seen if we are going with the statistical parameters. Image as the input instead of a plain original image as the input. So because of that now we can come to a conclusion. Now say this is our opinion. As an engineer, this is our opinion. But these images are medical images. So we are not expert while reading it. So we need to validate this data by doctors, whatever methods you have used. Whether these methods are better, which method is better, whether this type of a work is going to help them to find out whether it is helpful for them. So for that, you need to contact doctors and you should have a validate results by the doctor. So two images validation uh, I have it over here where all comparisons, because GSM and watershed I haven't shown here, but even that is implemented and these images are given in a one line and one box near or below that particular image where doctor has to write 1 to 5. 1 is the best and 5 is the worst. So in that case, so they have written like that 6 doctors we have contacted and this type of data we see. Now looking at the data, LBG, KPE and KFC both are at the same part somewhere. Okay. KFCG and LBG at the same level if you will see for image 2. And as we have seen that every doctor has their own opinion, some different opinions there. So finally we have to come up with some weightage. Some weighing factors are necessary because all opinions are not same. As we know that percentage is subjective. So since there is a considerable variation in the opinion of your doctors, the results are normalized using weightage. So here we have given the weightage as, so if one rank is given, in that case you will consider 100 weightage. If second rank is given, then 75, third 50, fourth 25, and if fifth rank is given, then it is a 0. So like that, the weightage is given for the ranking. And by using this, further we calculated whatever weightage was given, we have considered, and then we come up with this particular thing, where image 1, if you will see, for image 1 it is LPG 128 to 16, linear direct entropy. For image 2, it is KFCG 128 to 60. Then image 3, it is KP 128 to 60. For image 4 and 5, it is KFCG 128 to 60. So this is how we can see how which algorithm works better from doctor's point of view. And whenever we come with this complete addition, then KFCG is the best one related to mammography. And the second thing is that if three are almost above 2000, then which one we need to select? Then you can think about, or we can think about what is the complexity of every algorithm. So depending upon that, we can select and what is the MSC, what is the objective things which we calculate. So that can be done. And then finally, KFCG 128 is a winner for this particular comparison. So this was a case where we try to segment the image. So segmentation is the one part, because initial pre-processing part and for a feature extraction, this is the main thing. This is the, you can say, starting of your algorithm or your model. You can say model. And after that, now you have to go to your ML if you want to further make the complete system as automated. So how exactly now ML will come in? How exactly? So number of authors work on this, and they have come up with like a Webley transform for a feature extraction and physiology for classification. Then Zeng has come up with a combined K-means algorithm, which is support vector machine for breast cancer diagnosis. Then several work has been done in a clustering and classification. Okay, so that is what clustering we have used over here for a code book generation algorithm, and then we try to separate it. We haven't classified, but we have separated. Now, if we want to go with the classification, then your ML will come in. So in machine learning, feature selection is a process of using a subset of relevant attributes from various candidate subsets, and it is a prerequisite of your model. Whatever model you need to form, whatever data set you have, by using that, you will try to find out, or you will first select which features you should have so that you can have a proper, you can train your model properly. So feature selection is a very important point or an important step. So feature selection plays a vital role in creating an effective predictive model. Now, how exactly it is going to be? What are the various benefits for a feature selection? First of all, if you will select proper features, then it is effective and faster in training your machine learning environment. It reduces the complexity of your model and makes it easier to interpret. It improves the accuracy of your model if right subset is chosen. So then you can say that my system is much more accurate, and then we mention what is the value of my AUC. Okay. So generally we mention that my AUC in this category or AUC in that category. So AUC is nothing but my area under ROC curve, which we generally use. Okay. So this is how my feature selection is going to help me. Now this is one screenshot I have taken from one database. This is a breast cancer digital app. So BCDR. This is what I mentioned in that database data set slide. Now, if you will see at the right side, you have a segmentation part. Okay. At the left side, you can see is a patient information. Patient 3, age 64, gender female, whether you want to see a region, what type of images you want to see, breast, which is at the left side, any diagnosis has been done, whether what is the breast location, whether this is left or right, then what abnormality you have, whether it is a normal, abnormal, microcalcification is there, what exactly. Okay. So we will not go in detail of that. This slide is specifically to show you how the segmentation is going to help us. And if you will see this feature set which are selected, they have started with the area, perimeter, correlation, minimum, maximum, median, mean, standard deviation, statistical mode, inverse difference moment, X center mass, Y center mass. Because I initially also I mentioned that they generally give us what is the center of that particular tumor. Then luminance, kurtosis, all this roughness, shape, circularity, contrast, entropy, all these features are selected so that further it will help us. So now this is how we have we can see that how exactly our your data sets are using the different types of features. Now obviously these features are correlated or depend upon each other because they may exist a complex inter relationship between the features. So it is generally difficult to choose the best. So if I will select one and if I will not select other, but the next one, if am going to select the variance, but I will not select standard deviation, obviously it is not. So there is a interrelationship between features. So it becomes very difficult. So usually feature selection methods are classified into three general groups. Now how the feature selection can be done. So we have three steps. First step is a filter. Now in this filter step, what we are going to is we are going to rely on a general features, whatever general features are there for that particular technique that we will use. That is your general feature stage. So that will be there, and then you will use a wrapper. So generally we use a filter which is used in a pre-processing steps. Then when we will go with your wrapper, this is the technique where we are going to use a machine learning technique to choose your optimal subset of features, which subset you are going to select. So for that also we will use machine learning. So what we will do in a wrapper system, we will have a set of features and then we will generate some set of features over there. We will use a learning algorithm and we will check the performance. Like that, every time the set of your subset of your generated features we will use the learning algorithm and again we will check the performance. Like that, we will come up with the we can come up with the good subset of the features. And the third method is my embedded method, where in embedded method we will use a general features, what we have seen in the filter, and even we will use a machine learning technique also, and we will check the performance. So we will generate a subset and learning algorithm. That time only we will check what is the performance. If not good, then again we will generate another subset. Then again we will check and then only after we get the proper output, then only we will give the performance as a output and then subset can be selected. So this is a one method, any method you can do. This is the one generally method you can use. This is one authorized selected which I have presented over here. So this is how the feature selection can be done. Now after doing this, feature selection, now what you will do? So now after doing this feature selection, now some you can go with your machine learning algorithms. Some more of machine learning algorithms are there. So you can select any or you can select all. And how you will work? Whatever feature set you have, now you want to create one model. So what you will do? First of all, you will select some set of features. Using those set of features, you can select any one of it. Number of algorithms are mentioned over here. And then check what classification it is. You note down that. Second, and the same feature set you maintain and you check with another machine learning algorithm. Like that, you can check with all machine learning algorithms with keeping your feature set same. Okay, then you will have a one comparison, proper one comparison for one particular feature set. Okay. So then, like that, every time in a model, you can change your feature set, use your machine learning algorithm, come with your classification, and then you can, after getting these results for different combinations, then The next step will be a parameter optimization. Now, in case of your parameter optimization, you can use a programming, your genetic programming, which can be used, which you can change some values which are required initially. Okay. So this is the only point where the human intervention will come in picture, because otherwise everything can be automatic. But some parameters you need to mention in a GP, so only that much thing you need to input, and then finally you can come up with the best. So if we want to talk about the GP, it will first generate fixed number of pipelines based on your primitive, whatever we have selected, such as your first of all we selected some features. So then we have gone with the number of algorithms, machine learning algorithms, and now we can calculate what will be the classification accuracy. Now, if we want to calculate our accuracy, to find out our accuracy, we have to talk about what about your uh, true positive, then true negative, false negative, all that thing will come in picture. So you can use accuracy, you can use precision recall, okay, and then you can have your ROC graphs. ROC is nothing but your receiver operator characteristics. That graph you can plot, and then you can check the AUC. Now, when we talk about these type of different calculations, okay, and then when we come up with your AUC, area under ROC curve. So whatever AUC value you will get, your AUC value will mention clearly how exactly your model is working, whether your model is acceptable. If the value is between 0.7 to 0.8, if your values are between 0.8 to 0.9, then it is excellent. And if your values are above 0.9, then it is outstanding. If it is below 0.5 or somewhere there, then that much variation or non-discrimination has been done, proper classification has not been done. That we can say over here. So this is how you can do your and you can use your machine learning algorithms. Now the situation or the question is, how exactly we can say whatever we are doing and what will be the actual output, and how exactly we can mention, whether we can mention only if the tumor size, or whether it is benign or malignant, or something more we can mention with it. So for that, we have to know about what are the various staging in a breast tumor. So in the breast tumor, we have first of all one. Here we generally say TNM. This is the thing which they use, doctors use TNM. T is for your tumor, N for is your node, and M for is your metastasis. Now, when we say T, it means that it is talking about the tumor, and it is talking about what is the size and location of your tumor. So, along with T, whatever you will mention, depending upon that much detail, we will not mention. I will not mention over here. But along with T, if something is mentioned, it means that it is talking about what is the size and location of the tumor. If something with N, capital N is mentioned, then it is talking about the lymph nodes. Lymph nodes, because it may happen that the tumor extension generally lead towards your lymph nodes, and whether it is affected to your lymph nodes or not. So that is mentioned by N, capital N. And if M is there, then the cancer has spread to the other parts of the body. This will be mentioned with your metastasis. So that M will be mentioned along with that. If the further information is there, it is related to that. This is related how exactly you can mention which is in your particular image. Now, what are the various stages? When we say no, the cancer, any person, what is the stage? If we come to know that the person has a cancer, then the first question we check, what is the stage? Because even we want to know what is the stage, because the stage indicates whether something can be done or not. So here in this case also we have a four stages, where your stage zero is a tumor in place, but it is not going to harm. That is the stage zero. Stage one is a small cancer, but it is not grown. It is there. Small cancer is there, but it is not grown to a nearby tissue. Then stage two and stage three they combine together. Yes, cancer is of a large size, and now it has gone deeply in nearby tissue. And then your stage four is a very advanced stage. It has spread all over. So now we as a researcher, we all should know that how we should proceed so that the person who want to go with the biopsy, how exactly we can decrease that. Now the general procedure is when person takes when any mammography image, doctor observes that. Even CAD helps. After helping with the CAD, then we come up with like yes, tumor is there. If the tumor is there, then depending upon age and case to case, doctor may decide that yes, tumor should be removed. Now after tumor is removed, generally it is mentioned in that report also. You come after 1 year with your mammogram. So why it is mentioned again like this? Because after 1 year, after giving that particular, after that, whether anything more is developed in that case. Sometimes it happens that even though you remove that particular tumor, it may happen that if uh, some a small part is also there in that case also, that again tumor will form in that particular area or it may spread. In some cases, even though after removal of your tumor, some chemotherapy or radiation sessions are necessary. Now, chemotherapy technique is a very problematic technique, I should say, because that the particular drug is going through veins, protein cell, and complete body. So it is going to affect on our complete body. So it is very painful for that patient. So if we want to avoid all these things, then it becomes very necessary that every woman should go for the early detection of their pregnancy. Now consider as a person, if I will go to a doctor and I know that now I'm going for this mammogram. So obviously, in my mind, I will have a question. Now, if cyst is found or if the tumor is found, how exactly doctor is going to treat? And to consider if you have a system or a one model with a doctor where doctor can give an input, your mammogram as input, and can give an answer to patient that if this is your mammogram, then this can be not a, you can say 100%, but this can be further treatment which can be given. Now, when it is possible, when it can be done, when you have a model with you where you can give this as an input. Even in some research also, if some doctors want to use some new drug, in that case also, they will first of all, like in our case, generally we do simulations. Instead of directly going on the hardware, what we do, we generally go for different types of legal software or different files and all that, multi-sim or all that we will use. And then we do all parts, then we give input, then we simulate it, and then we check. So imagine from that point of view, if it is possible for doctors to do this, then this is such a beneficial thing for a patient. So what we can do in this case, we can have a model where we can input that particular data. As we know that we have a 4 stages. We are starting with the pre-processing, then we are going with the feature extraction, set we are selecting, then we are going to the machine learning, and then we are going with the parameter optimization, and then the model is complete. Now, whatever input you will give, and even we checked our model by different types of results. Now, different variations you can do on your own, whatever variations you want to do in particular model, so that the response can be very good as compared to the previous. So when we generally go with the number of algorithms, then we come up and we say that result is very good. If we compare these two, then the result is very good for this particular algorithm. But at that time, we have to check this complexity. At what cost you are seeing this, whether practically it is possible, how much time it is taking. So even we need to think from that point of view also. It is like no lunch free. Every algorithm cannot be a good for every type of image or every type. So, like if we are discussing about mammographic images, if we will come up with some specific technique and this technique works better in this case, if this is not true for MRI images, because every modality has its own advantages and disadvantages. Even the images which we can use is in a different format. So because of that, it may change. So how exactly your post detection utility, or you can say after post detection, how your ML and AI is going to help us. Every time a new drug or a treatment procedure for treating your breast cancer is developed, now a lot needs to be done before actually using this methodology for healing. Because something new drug directly you can use. Now you just imagine so many days we are trying for a COVID vaccination, but still that vaccine is not there, and so many different techniques we are using. So any new drug and treatment of that is very a big procedure. Okay, now, if we want to do this in case of your breast cancer, then how ML and AI is going? Because we have a model. So ML and AI can together synthesize the data of patient and create appropriate test cases and predict how the treatment course will work for the patient. Now, this thing we can first train. It means that by using that model, first of all, for patients whose data is already there with us, or treatment was already done that is there with us, if all information is there with us, by using that, we can train it and we can predict it, and then we can check whether it is right or wrong, whether it is matching with that. If it is matching, we can find out our accuracy from that point of view, and then your final model will be there. Then this model you can use for your treatment process. So this is a case which I have discussed. Oncologists have observed that every time when women comes to book an appointment for the breast cancer detection, she is more concerned to know how she will be treated if she is diagnosed with cancer. Obviously, this is a question even in my mind. So with such a handy AI tool at hand, the doctors can know beforehand how the cancer treatment is going to work on case to case. Obviously, every time treatment will be different. As I mentioned, it depends upon at what stage your cancer is. It is related to what stage. If it is not going to harm at all, if it is a benign, then you will not think about the removal of it. But if it is a malignant, then obviously removal of that particular portion is important. Sometimes it is also possible that it is so small that using only chemotherapy techniques also you can do. That depends upon what is the health of that particular patient. So case to case, on that basis, you can change it. So, but by using this particular thing, we can have a particular, you can say, roadmap or treatment in our hand, and on that basis, something can be selected, suggested by the doctor. So, overall, new technologies such as machine learning and artificial intelligence have given a lot of hope to disease specialists. Because we know that if this is going to help us, then obviously, if we will work in this area, it will help doctors to further go with this. So, this is where I finished with the today's session. These are all references Now we can go with questions if any question is there. Still we have some time and we can discuss some points. Even if we can have some discussion, if anything you want to share with me, I will be very happy with this. Anything in the chat box?
Hello,
Yes,
can you hear me?
yes, yes, I
Sorry,
can
there
hear.
are few questions. Like whenever we are doing the image processing,
Yeah.
which format, in which format the images should be, like in biomedical case?
For mammographic images, we can go with because compressed image we generally don't use. Otherwise, all properties which are already compressed. So generally, we go with the BMP images. And nowadays, we are using JPEG LS also,
Okay.
LJPEG, which is a lossless JPEG.
Okay.
So that can be.
So is it DICOM images like compulsion that the
Yes, yes,
DICOM?
DICOM. Actually, specific software they use a DICOM images only. So in that case, you should have that setup there where you can see those DICOM images. Because
Yes.
when we use some files, no, it gives us an indication that only DICOM images can be open. Even now, initially when I used Minimia's database, that time it was so easy to download from there. But now when I want to check Minimia's database, that time now I have seen different format is there. It is not BMP which I have used at that time. So they have come up with some new extensions also, and DICOM images are yes, DICOM images are there. I have also seen for some cases.
Okay. The next question is that you have told so many classifiers, SVM, KNN, and so on. Can you tell about the accuracy and which will be useful? In which case, is it like that?
Now, if we want to compare this, no, then in that case, in some cases, the results have shown that it is better for uh, like here I will go for the list. Finish also.
Hello.
Yes, yes, this is the list. No, okay. Out of that, they actually come up with the ADA boost classifier, where you have your better EUC, but the problem was with the log loss. That time, the log loss value was little bit variation. But then they come up with the last one, which is your linear discriminant analysis. So in some cases, they have come up with these two. Even SVM is also showing a good result. K nearest neighbor is also showing good. Comparatively, they are good relative to other machine learning.
Okay. This accuracy and the time complexity, whether it depends on the machine, like or whatever the GPU machines or CUDA, whatever the things like that.
Yes, yes, yes. What exactly you are going to select now to perform, on which you are going to perform it will matter.
Okay. One more question. Can you suggest few research areas in biomedical field so that the participants can start their work in that particular area?
Yes. See, in mammographic images, now as we know that there is a problem because we can see that whatever is the density of that particular tissue, if something is behind that particular, any tumor is behind that particular thing, then your false alarm is there. That is what comes in a limitation. So we can come up with some technique where this false alarm can be reduced. And if we can do that, then it can be accommodated in your model. Because if you change only pre-processing also, no, in the very simple way also you can improve your accuracy of the complete model. So it becomes necessary that even though we are going with the mammography, if we compare the study of mammography and MRI, very good results actually as compared to mammograms. But the issue is MRI are costly as well as the technique is totally different. So whenever anyone suggests you to go for the MRI, then we are like, what has happened? Why MRI is suggested? So people doesn't take it in that way. But for mammograms, it is okay. So now the basic difference between these two, what we are achieving by mammograms and what we are achieving in MRIs. If it is possible with mammograms to get that type of result by using different image processing techniques on mammograms, so that will help because it will reduce one step, next step when we say that mammogram is not going to work now, you have to go with it. If you will reduce this particular step, then it is much more. There you can use
Yes.
it.
Now we are towards the end of session. Good
Okay.
morning, one and all. Good afternoon, one and all. Actually, on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of ENTC, I, Dr. Swati Bisikar, take this privilege to propose vote of thanks for today's eminent speaker, Dr. Saylee Gharge, who has given the interesting talk on image processing and mammography related all the technical details she has covered. Thank you, madam, for sparing your valuable time with us. Thank you very much. Thanks a lot.
Thank you so much.
Thank you, ma'am.
Yeah.